understand data structure, first we'll go to the introduction. The data structure is a scheme for organizing data in the memory of a computer. Some of the memory commonly used data structures, which includes list, array, stack, queue, heap, tree, and graphs. This is an example of a binary tree as shown in the figure. And basically it's a spanning tree. Now the basic of this data structure, the way in which the data is organized, which affects the performance of a program for different tasks. The programmer decides which data structure to use based on the nature of the data and the processes that need to be performed on that data. For example, a queue. So what is a queue? A queue is an example of commonly used simple data structure. A queue has a beginning and the end position. The beginning is called the front and the end is called back of the queue. Data enters the queue at one end and leaves at the other. As you have maintained the queue in booking cinema tickets in the cinema hall. Because of this nature, data exits the queue the same order in which it enters the queue, like people in checkout line in the supermarket or railway reservation counter or your cinema hall. The other example is a binary tree, which is commonly used in data structure, and it is organized like an upside down tree. Now in this figure, each spot on the tree called a node, which holds an item of data along with a left pointer and a right pointer. This is the figure example of a binary tree, which is a left pointer and a right pointer. The pointers are lined up so that the structure forms the upside down tree with a single node at the top. It is called the root of the node or root node, root of the nodes or root node, and branches increasing on the left and right as you go down the tree. By comparing the queue with the binary tree, you can see how the structure of the data affects what can be done efficiently with the data. The example is given. Now, a queue is a good data structure to use for storing things that need to be kept in order such a set of documents waiting to be printed on a network printer. If a number of systems are connected to network and the printer is only one for all systems, then a queue will be maintained for the different files or documents to be printed by the same printer, as shown in the figure. Lot of files are there and they will maintain a queue or to be printed in a single printer. And the jobs or assignments will be printed in the order in which they are received by the printer. Most of the network printers, print servers maintain such printing queue. The binary tree is a good data structure to use for searching the sorted data, which already have been sorted. The middle item from the list is stored in the root node, with lesser items to the left and greater items to the right. A search begins at the root and the computer either finds the data or moves left or right depending on the value for which you are searching or the user searching. Now each move down the tree cuts the remaining data in half. Items can be located very quickly in a tree as the telephone directory assists by giving the information stored in a tree so that a name and phone number can be found quickly. For some applications, a queue is the best data structure to use, but for others, binary tree may be better. Now programmers choose from among many data structures based on how the data will be used by the program. So what is the need of the programmer? It has to choose that structure which will be give more efficient result in quick time. Go to data structures in Alice. Alice has two built-in data structures that can be used to organize data or to create other data structures such as list and array. Now the given two figures segregates the difference between list and array, which are shown in the figure, where the girls are standing in a field. You can visualize the difference in the podium of their standing position or in the field where they have a present in standing position. With joining the hands in arrays, but the hands are not joined in list. I'll go to list. List is an ordered set of data. It is often used to store objects that are to be processed sequentially. Thus the list can be used to create a queue. Now we go to array. An array is an indexed set of variables such as you've seen in the figure. And if they also treated to be dancers, dancer 1, dancer 2, dancer 3, which forms a set of boxes that holds things. That means here the dancers. So dancers are standing on a set of boxes that are set of podiums, you can say, or boxes. A list is a set of items, but an array is a set of variables that each store an item. Now we compare arrays and lists by giving figures as shown in the example. You can see the difference between arrays and lists when you delete the items. Now we'll go to the list. Before deletion, 5 dancers are there, and after deletion, we are removing the middle of the dancer, and what you are finding, again they are minimizing the gap between the dancers after deletion. So they are having compact positions after deleting the middle dancer from the list. But in array, if you are having 5 dancers closely compact to each other, and you are moving or removing the middle one from the box, middle box, then that box will be an empty one, and other dancers are to be present in their original position. They will not move to close the gap between the dancers. So this is a basic difference between array and list. List, the position will be compacted automatically after removing any data of the list, but in array the position will remain vacant if one data will be removed from the, or one item will be removed from the set of data. In a list, the missing spot is filled in when something is deleted, what I have given in the slides. But in array, the empty variable is left behind when something is deleted. List is created in lists by checking the make a list box and creating any variable. Here you can see the make a list box. Containing different type of objects. The for all in order and for all together. Tabs can be used to work with lists. They are at the bottom of the editor area. Arrays can be created in a similar manner. More often, they are created using the array visualization object from the alias local gallery. The array visualization object has special properties and methods for manipulating the elements in an array. The example is given for array visualization. Alias has a set of built-in functions that can be performed on arrays